The pull-out force test is the key test to test the firmness of the combination between the steel wire thread insert and the bottom hole. In the test, we use professional equipment to apply axial tension to the test piece, with the wire thread insert gradually increasing the tension until the wire thread insert is pulled out of the bottom hole or the bolt is pulled. The maximum tension value recorded in this process is the pulling force of the wire thread insert. The size of the pulling force directly reflects the holding force between the steel wire thread insert and the bottom hole. The greater the pulling force, the more firmly the steel wire thread insert is fixed in the bottom hole, the less easy to lose or fall off when subjected to external forces, such as vibration and impact. The torsion performance test is mainly concerned with the performance of the wire thread insert under torque. We install a threaded connector with a wire thread insert on the torque test equipment, then apply torque to it, and observe the change of the threaded connection as the torque increases. This test can find out the deformation of the wire thread insert under different torques, whether there are slipping teeth and other problems. Comparison of M-Liu wire thread insert. As an example, taking the common M-Liu wire thread insert as an example, we compare the performance of the ordinary bottom hole thread and the embedded screw thread in the pull-out force test and the torque performance test. In the pulling force test, the cast aluminum A12 ordinary M6×1 D bottom hole thread has a tripping phenomenon when it is subjected to a pulling force of about 14.4 Rn. The screw thread with M-Liu wire thread insert is installed, and the pulling force of the test bolt can reach more than 23.18 kN with different degrees, and even put the test bolt and the wire thread insert assembly is not damaged. In the torque performance test, the ordinary cast aluminum ZL101 M-Liu bottom hole thread showed obvious slip and deformation when the torque reached 8.7 Nm, and it could not continue to transmit torque normally. The thread loaded into the M-Liu steel wire thread insert can still maintain good working condition when the torque is increased to 19.53 Nm, and even continue to increase the force to break the bolt. The thread has no obvious damage, and the torque transmission is stable. Through this set of comparative data, we can intuitively see the obvious effect of steel wire thread insert on improving the torque performance of thread. In summary, the wire thread insert has shown excellent performance compared with the ordinary bottom hole thread in both the pull-out force test and the torque performance test. Its role in strengthening the bottom hole thread and improving the thread torque provides a more reliable and durable solution for threaded connections in mechanical engineering. In practical applications, the reasonable selection of steel wire thread insert can effectively improve product quality, reduce maintenance costs, and extend the service life of equipment.